Good afternoon, everyone. I'm Zou Haixin, a research student from China. Today, my topic is about the jingle nuts, detection for the front and back sides. Let's take a look at the outline. My topic is divided into three parts. First is introduction, and then the materials and methods. The last part is results and future plans. First of all, let's take a look in the jingle nuts. Jingle trees, we all may familiar with the jingle trees because they are grows around us. Just in our campus, we can see jingle trees here and there. Because of it has high value. Maybe some mistake. Because it has high values of the. Yes, here. Because it's high value in nuts and leaves, because they can make into nutrition, medicines, veterinary drugs, biopesticide, cosmetics, and etc. So it's a very valuable jingle. It's kind of valuable trees, and actually it has long histories of cultivation, maybe more than 3,300 years in China, and actually it's an ancient plant. Just exists in. I think there's some mistake here. The PowerPoint is not so clear here. I'm sorry. I think I haven't checked the. Yeah, it's my review.
Font is different. You use the special font?
Yeah, I think I copied the wrong PowerPoint. Maybe this is okay. Actually, it's an ancient plant. It just exists only in some limited area. But thanks to the cultivation techniques, now it's not only grow in China, but also in Japan, Korea, USA, and France, New Zealand, Canada, and so on. So it's kind of all over the world. And now jingle trees in Japan. As I said, you can see jingle tree all over. It's just along the road. So it's grow all over Japan, especially in Aichi, Fukuoka, and Oita. And there's all kinds of types of jingle trees, such as Tokura, Kyuju, Kinbei, Lennon, etc. It's about it says that producing about 900 tons of nuts per year. So it's a very variable nuts and all kinds of purpose. So the process of the jingle trees is first harvesting and then selling, and then go on to the other process. And now I am focus on the shelling. State the problems. So as for the shelling, we use the mechanical sheller. The sheller has a high efficiency and labor saving, but the success rate, as you see here, is success rate and the crash rate is not so good. So we might use the precise shelling just one by one. That can increase the success rate and decrease the crash rate. But the problem is shelling without the knowledge and the front side and back side will affect the success rate. So my objective is to develop a machine vision system to detect and tell the front side and the back side of the jingle nuts. And now this is the definition of the front side and back side. The front side here maybe has some tip, kind of sharp here, and while the back side is a kind of round. As you see later, maybe the front side has this image is taken from the front side. Maybe have some clear line here, while the back side don't have this kind of line. So this is the material and device I use here. This is hemisphere reflector, just to create a an even light condition. And this is halogen lamp with PL filter, and this is IRA filter, and this is cameras, and this is setting. This and the camera connects to the PC and the capture board. And this is the edge detection. This is original image. As you can see, this is a Tokuro type of jingle nuts. So this is the front side. Front side out, you can see a very clear edge. This is processed by Sobel filter, the edge detection. While here is the back side. Back side, maybe no, you can see the line goes and stop here. And here is kind of blurs and disappear. So the other two types Q2 may have the same pattern, have a line in the back, in the front side, while there's no line, no clear line in the back side. So this is another type Kinbei nut. So as we can see from the image, they have good quality. The front side has well-defined and continuous lines, while the back side is kind of blurred and no continuous line. There's a high possibility to distinguish by using the machine vision. So here is my hypothesis. The front side we can find the line, while the back side we cannot find the line. Just instead of line, we can find maybe curve. So my mission just turned into find the line. So the process will be like this: original image acquisition, and then edge detection, and then the binarization. Finally, we can get the line. Here is how I process this image. The original image and the binarization image. This is the edge detection image. This one is extract from this image by extract the last line, just like this. So this is the areas of the front side. You may not see very clear. There's some part because the front side is like here, the areas. So the area of here, front side, we might properly find the line here. The red line here is I use the linear least square method to fix this the front side. So in areas here, maybe we can see very straight line. They match together. And while the back side, I use the same process. While here is the back side, it's kind of fluctuates here. So in my the same method was used. So in my the result is based on the hypothesis. Based on my hypothesis is Q2 has 85%, and Kinbei 80%, and Tokuro has 75% to recognize the front side and back side. Maybe some problems such as light condition and threshold of binarization. Here is an example. You can see the original line here, original image here. Maybe this kind of belong to Tokuro. Yes, it's maybe good if it lies horizontally, but in this condition it's bad. The binarization and the edge detection. You can see the line is gone here. Instead, it's just goes into another way. So in this case, it's wrong because of the fluctuate. It goes against my hypothesis. We cannot find the line in the front image. So I think there's maybe some improvement here. First of all, is light condition, and then the threshold of binarization and compensation. And I think the threshold binarization is kind of difficult because you cannot find a universe threshold for every image. This one is maybe difficult, very difficult. I think easier one is light condition. We can change light condition and then make some compensation. find find another way to extract the line. So it's maybe another alternative could be used, but I'm now still working on that. Yes, I'm looking for another alternative. Yeah, and then my future plan is maybe a new setup with 2 cameras and work in the moving condition. Now because it needs to deal with the moving condition while the nurse is going in a line in the machines one by one. You may not stop the line and take the image because it's time consuming, and we want to improve the efficiency. So we should in the future deal with the moving condition and maybe use 2 cameras to increase the success rate. That might be all of my presentation. Thank you very much.
Any question?
I think your problem comes from the light condition.
Oh.
In your case, you set integrated hemisphere on the top of the sample.
Yes.
You see by camera.
Yes.
From side. But I think how do you think about to set the hemisphere to the same side to the camera?
Same in the same side.
Then light comes to the same side to the camera.
Oh.
In your case, the light comes from the top, so you cannot see the bottom side.
Oh.
I see.
Okay.
How do you think?
Because I think the most important in my method actually is this may be one of the methods. It's not the one method. This is one of the methods. I think we need to extract these lines, and the best condition I think would be from the just right in the top on the top of this nut, such as this in this image, the light is come from the top. But if the light come from here, just right above this face, so the line will become very clear, because the line here will because it's come out a little, just cover the bottom side. So the light would be if the light come from the right above the here would be very good. And as you can see, the problem one. Oh, sorry, wait a minute. The problem, yes, the problem. If this image, the light condition, the light could light like this. Yes, there will be no so much bright here, and then the line would become more clear. So I think the best light condition would be adjust according to the face, the surface, and the top side and the bottom side. But I think it's not. It cannot be done according to the top side and the back side, the top side and the bottom side. But in your method, you mean with take the line with the camera. This is camera, and the light is on both sides of the camera. Yes, and take the image. And I think in that case, they will just light the top side and the bottom side up. Just light this line will not be very clear. Yeah, will not be clear, because in my method, just only in case of my method, there may be some other methods. But in my case of method, if you if I want to use the binarization, that may not be good. Yeah, from the first
So
part.
in your case, you don't need to see the bottom side.
Yeah, I don't want to see the bottom side, because in this case, the bottom side will will affect the line. So in my case, I want the light come from just right above the nuts top side. So, but the nuts usually just not lie horizontally, just like they will just like this. So it's kind of hard to take the good image, and in my method, there may be some other alternative to
I thought your system is best for horizontal right.
Yeah. But not good. Yeah, when you have to have the position like this, this not good. Yeah. Thank you.
Relating with that discussion,
Yeah.
I have some suggestion.
Yes.
That is why don't you use the active lighting way?
Active lighting.
That is, you just a passive image. Active lighting condition is LEDs. LEDs consist of many small lights. Then from right to left or left to right, on off, move. Light off, light on, off, something like that. Then you take several images.
Oh, okay. But I think I didn't find this kind of equipment in our lab. Maybe I'll try, and I'll seek some for help. Yeah. Try.
Any other suggestion?
Comment? Just small comment. Actually, at first maybe after in the introduction, you better have one or two picture about this nuts, because in the first I don't know that kind of nuts.
Oh, okay.
But
Okay.
of course, in the after that, because you mentioned in the slide, I think in the beginning. So
Oh, yeah.
when you introduce about the implants, so picture will help.
Sure. Thank you. Okay.
That's a good suggestion.
Thank you.
After introduction, after background, you need the materials.
Material.
You have no materials.
Yeah. Maybe I have. Wait a minute.
Then what did you?
This is material. Material defining. This is yeah.
Material.
Yeah.
Then hopefully what kind of tree?
Oh, what kind of tree?
Yeah. So
Oh.
maybe some of them have no knowledge about.
They are grow just downstairs, or you can find them. Very old tree. Yeah, I will add that next time. Okay.
Also, another suggestion is, if possible, why don't you show us the outline of the company machine system or something? Then which part you are taking as your project?
Okay.
That would be easy to understand for us.
Thank you very much.
Any other suggestion? Okay. Thank you very much.
Thank you very much.